Hi, this lesson is about Newton's second law of motion. Let's cover the basic definitions, concepts, and some examples. To better understand the second law of motion, we need to go back to the first one. The first law of motion is about inertia, and it says that we only change an object's movement if there's an external force acting on it. So it's reasonable to say that the acceleration resultant from an external force is proportional to this force. Also, that it's inversely proportional to the mass of the object. It means that the greater the external net force, the greater the acceleration, and the greater the mass, harder it is to accelerate this object. Remember, it's always an external force, so that's why this is impossible. He's trying to pull himself up, but it's not possible because it's an internal force that's acting on him. And this, it seems a little bit crazy, but it is possible. It's an external force acting on the object. So we know that the acceleration is proportional to the force of the external force acting on an object and inversely proportional to its mass. Therefore, we can express the second law of motion as force equals the mass times acceleration. We use newtons as the units of force, and it's the same as 1 kilogram times meters per second squared. Some examples can be someone trying to push this box up in a ramp, and well, the external force needs to be something like this in the direction he's trying to push, but we also have some other forces acting on this object, like the weight and friction. Another example can be when you have electric charged particles and they are repelling or attracting each other, and then you have a resultant force. Remember, these are vectors, so we need to add the vectors considering their directions. If you want to know more about these electric charged particles, you can take a look into the Coulomb's law video we have here. Okay, let's practice using this example here. We have that man trying to push the box up on this ramp. The mass of the box is 10 kilograms and the friction force is 1 Newton. Also, the angle of the ramp is 30 degrees. So how much force must be applied for the box to start moving up? Well, first we need to add these forces and then know the resultant force. So to make things a little bit easier, let's take the ramp angle as our reference. So we have this thing here. We have the resultant force in this direction going up, and these two other forces on the opposite direction. We have friction, and if we add these two vectors here, we can now know how much force must be applied. But the weight acts in two different directions. We can decompose this vector into other vectors in the y and x components. So the only component of the weight that's acting against this force, the resultant force, is actually the component that's in the same direction of the friction. So we know this is a right rectangle, so this alpha angle is 30 degrees, therefore this angle between the friction and weight is 60 degrees. So we can add the component of the weight and the friction that are in the same direction, and we would have a resultant force of negative F. Well, let's just apply the second law of motion. And first we need to know the weight. And in this case here, the weight in the direction of the ramp is equals m times cosine of beta times the gravity, or the mass times sine of alpha times gravity. Doesn't matter, they'll be the same, they'll have the same result. So let's use the sine here because we already have this angle. So applying the second law of motion, we have the mass of the object, 10 kilograms, times the sine of 30 degrees, times the gravity acceleration, and this gives us a weight force in this direction here, the ramp direction, of negative 49 newtons. So we add this weight component with the friction, so we know that the resultant force must be greater than this resultant force in the opposite direction for the box to start moving. So any force that is equal that's greater than the resultant force in the opposite direction will lead the box to start moving up, and this force must be greater than 50 newtons. Alright, now it's your turn. Think about what happens to F if we increase the alpha angle to 45 degrees. So will it increase, decrease, and how much will it change? Also, if instead of changing the angle, we change the weight of the box, if we decrease, for example, the mass by 10%, what happens with this force? So think about it and write your answers in the comment sections, and see you next time. Thank you.
Cannot find a topic you're struggling with? Tell us in the comments section and subscribe to make sure you're first to know when we cover it.